So welcome to session 2. Good morning. I suppose this morning it's more recent adopters of Csound and more very interesting, very diverse project again, which is good to see. And we're starting with Martin and James, who are studying their undergrad in production and have got an Enterprise Ireland scholarship grant type thing to build this educational software.
Thank you, Brian. We'd like to thank Brian and Jeffrey Hearn for inviting us to work on this over the summer. We're students kind of sound engineering, as you know, and so a lot of these tools that we designed relate to making sound engineering tasks easier to teach to students where, like virtually, in a virtual environment, and that's something that we thought hadn't really been done before. So here we only have 3 slides, and the rest of it will be just basically showing you the 3 tools that we made. So this is, well, you can see them there anyway. So yeah, basically there's a a signal flow virtual mixer, which is just a signal flow task for students. There's a graphic EQ to tune a room virtually, based on IRs, and there's a feedback based on mic position, the effective EQ and gain staging and how that affects feedback. And this was all done with Rory's Cabbage and Csound, of course. So thank you, Rory, for all your help during this as well on the forum. Yeah, so I went through the various things there. So the reasons that we wanted to build these was due to these factors. The cost of booking a venue to teach live sound can be quite expensive. Facilities, also many colleges don't have access to a dedicated live sound area, and there might be a need to learn off-site. Luckily, we have the Button Factory in our college, so we have that, but other schools mightn't. Then efficiency, so with customizable options incorporated, our tools may allow tutors to provide students with a more focused learning experience. So yeah, we'll start off with just opening the Cabbage file of the first tool, which is the Recursive Mixer. And Jay will run you through this. James, sorry. Does anybody know how to get the resolution correct for a MacBook?
It's been display settings or the utility, yeah. Should do it on my
Beside your iTunes logo on the bottom there.
Yeah.
No, next,
yeah. Sorry about this.
Yeah, sure.
Oh, the window underneath.
Oh yeah.
The top one, no, I think there's a top one.
The very top?
Maybe it is the other one.
Sorry. Stephen thinks it's the other window.
Sorry about this.
Yeah.
See this.
Yeah, maybe it is. Arrangement. No, maybe it's that optimized for. And then the other one you do the same.
Okay,
Yeah.
looks like it should do it. Apologies again.
Good morning, gentlemen. We'll just get it on the screen here. Okay, so as Martin was saying, the idea of this project is to provide students with a basic signal flow and routing task. It also incorporates some basic mixed features as well, which were a bit supplemental to the project. So we have... should that not be running, Martin?
Yeah, sorry, this one.
So we have a multi-track Marvin Gaye here, broken into 8 individual files, and we can we can solo, we can mute, we can pan side to side, and apply basic EQ as well. But also along with that, that's for the front of house mix. But we can isolate both pre-fader and post-fader sounds to create on-stage mixes, maybe headphone mixes, or a stage mix for, say, a drummer. So if this was being set up for a drummer, he might want to hear lots of the bass line, which I'd like to hear there too. There we go. Okay, so you bring that through maybe, and he maybe likes some vocals as a bit of a guide, and perhaps some guitar. So this will be isolated to the front of house mix, where the audience would hear everything else that's going on. The drummer might hear just the individual mix. And that can be set up again for a headphone mix, both pre-fader and post-fader. I say this. Now, can we hide this toolbar?
I don't know how to.
Go back to the settings. I think there's an auto hide thing in the settings. Isn't it?
Yeah.
For the toolbar, you can auto hide it. Just
On the bottom?
Yeah, the bottom. Somewhere, yeah, if you close that one now.
So yeah, close that feature.
And somewhere in there.
Dock, that's just above there.
All right. Okay.
Left.
Oh yeah.
Auto hide.
And automatically hide. Okay.
Oh.
Cool.
Yeah.
Learning loads.
Okay, excellent.
Confidence
Okay.
keeps giving.
Yes.
So the idea that this would become an educational tool is that we have an admin panel down here at the bottom, and basically all these widgets create values, and those values can be stored directly into an F table. So we can have an F table set up as a preset table at the beginning, and you can, by hitting the compare here, the green line there, I should say, at the bottom of the screen, if it can be seen, that would be the preset values, and the blue line would be the flat default values that are dialed in at the moment. So if I was to hit compare here, we'd see that the green line and the blue line should almost they should match up, showing that all the dials are in the preset positions. If I was to move, say, this pan knob over here and then run a comparison again, then we'll see on the red line there at the bottom, it can be well, the red line is really just a graphical display of the F table that's showing that there's a difference between the preset values and the new values that have been created by the user. So this allows a tutor or a demonstrator to create a mix, to create certain gain stagings, and then to store those values for another student or for another user to come along and create their own mix, their own comparisons, and then compare the two to see basically how the student is coming along. A lot of this is going to be subjective, I suppose, because people can have their own creative thoughts on the processes. So it is really just a basic tool for a proof of concept at the moment. And default values can be restored there as well. So I think we'll run on to the next tool.
Yeah, cool. So, luckily enough, the next tool should fit on screen. So this is the virtual room tuner, and this is kind of based on a kind of industry standard graphic EQ, which has 31 bands. There's third octave Q. There's an overall kind of fader to control the overall graphic. You can bypass the EQ. It also has the same kind of admin panel that you saw in the model that Jay just showed you. Here you kind of choose which impulse response reverb you want to kind of, so basically a WAV file is played for the student. The idea is that the student gets a random WAV file and then has to make it sound within this virtual space, and like there might be a random IR thrown in there, and it's up to them, and the curves can be made again based on presets and the score calculated based on the deviation from the ideal. So yeah, I'll play it So I just picked a loop that we basically noticed. What we did initially, we got IRs online, freely available ones, and we found that they didn't really take off. That's what we kind of call it in sound engineering, when like a certain frequency takes off within the room. So we didn't really hear anything, even in the kind of hall one. It just sounded just kind of boomy more than anything. So we took our own one in a small size rehearsal room, and we drove it through kind of a full PA with subs and everything, and we used an SM58 microphone just to add loads of coloration, and eventually we got an IR that really takes off with this particular sample. So I'll just play it with regular IRs. So that's just a room. I need to play it loud, sorry. So that's just a room, regular one that we kind of found online. The plate kind of... So you don't really hear anything kind of taking off there, but in our, the IR that we took, you can hear that when she says park, it's 1046 hertz around, like so C6. It really kind of, you can just hear it kind of taking off within this virtual space. So basically, we found then that taking down, so the student would hear that, and they would take down bands 19, 18, and 19. So it's around there that it is. And then the preset score will be put in by like somebody who's a trained engineer already, and they will compare their score against that. And the red line at the bottom then would show how close they are to it, depending on slider position. And it has the same functions where you can compare. This is where the tutor before would store the default, move the slider, and then the student sees how close they are to the default, and then your deviation is shown here. And then based on that, you can tap into this red line deviation to kind of calculate the score, and that's how the lesson would run, basically. So that's that model.
What filters do you use?
Pardon?
What filters do you use?
Inside,
just curious. It's
Butterworth bandpass.
Butterworth, okay.
we can show you the code after if you want to see it. So we'll move on to the last one. So,
some competition there.
Okay, again, this tool is it was designed for proof of concept, so it doesn't have the same analysis features as the previous two tools do. The idea of this is that is to demonstrate some of the components that will lead to the onset of feedback or howl around, which is, if you're not familiar with it, is that annoying ringing sound that happens sometimes with live sound equipment. And we're hoping to demonstrate that the situation that would lead to feedback would be more dependent on the level of system gain rather than on the level of the original sound being inputted to it. So if you can assume that this source here is an actual speaker outputting, can we get a little more volume?
Yeah.
Okay. So we're getting feedback there, and if I move the microphone away, then the feedback should die off. This is something I was actually talking to Rory about recently, about using SVGs, that we can replace the knob of a standard widget with any image that we like. And I've actually mounted it then onto a H slider, or sorry, onto a V slider, so we can move the whole lot in and out. So you can have virtually, you can place your microphone along a linear path and give it some rotation. Now there's a polar pattern built into this. It's a very basic logarithmic polar pattern, and that we hope that in future versions we could model even actual microphones. So you can hear the feedback starting to ring there. As we get close to unity gain, as it gets close to, there we are, then we should hear that it begins to ring, but it won't quite feed back. Hopefully somewhere there. There it is there. So And then when it returns to Unity again, you pretty much definitely get feedback. So the way to avoid this would be to lower the gain on your system and to bring your microphone in closer to the sound source. When you do that, you can even turn up the input volume and get quite a loud signal with a wide signal to noise ratio and without the feedback. And again, we have this set up for room, hall, and plate IORs. Okay, there's also a graphic EQ on it, and the graphic EQ can, as the feedback comes in here, the indicator should demonstrate, or should display at the top, where the feedback is actually occurring. So this might get a little bit loud. There is a limiter on it, so I shouldn't bounce out too much. And you should see up here any moment now. Thanks.
There it is.
There we go. Apologies. We got our display at the top there to show us what frequencies are. Well, it's the fundamental of the feedback pitch. And now the pitch of the oscillation is going to relate to the loop time, the time it takes for the signal to travel around through the speaker through the whole system. So we've included a short latency of about 20 milliseconds to simulate the latency of a live sound desk, or the time it takes for the sound to travel through the medium. So that can be adjusted as well, probably in later versions. So I think that's about it for this tool.
Yeah. I guess like for all three tools, we tried to minimize on code as much as possible. So as there's a lot of repetition in each with like similar sliders and stuff, we found recursion eventually was the way to go. So that kind of shortened up the code quite a bit, and we were able to kind of use arrays creatively as well.
For the mixer tool, we had a previous mixer that had a few more features, but the code was 5,000 or 6,000 lines long, and we were only learning how to put this together properly. So on the new one, we've managed to get it under 300 lines of code, which we're still patting ourselves on the back a little bit for that. But we've got a long way to go, I think, and hopefully we stick with Rory and Cabbage and get through this.
Yeah, just wanted to thank again Rory, Brian, Jeff, Brian Cahill, and Sound Training Centre, IADT, and all the people on the Csound forum who helped us while we were working on this. So, happy enough. Okay, thank you.
Thanks very much.
Any questions? Thanks, guys. Anybody have any questions?
Thanks very much. Especially the third tool is awesome. It's great. It's really good. I was just wondering, in relation to the third tool, would there be scope? I know there's obviously scope to do it in the code, but I'm just mean on the GUI. Would there be scope for inputting, like recording impulse responses of a specific room and then having them in along with your plate and stuff? So if you wanted to teach someone, this is the room you will be working in, you know, to actually specifically do that, so they know the room before they've even stepped into it, for example.
Well, the way it's set up at the moment is there's within the folder with the script, there's 3 IOR files just named there's WAV files named 1, 2, and 3. So any file you put in there with your own name, with your own 1, 2, or 3, and your own IOR will be drawn into the script. So
but there's like you have to go into the source to do that.
No, you can just do that through the folder itself. It's just dropping your WAV into the folder.
Okay, yeah.
Mm-hmm.
Okay.
It'll auto-populate the drop-down menu.
Okay, sweet, that's great.
And pconvolve is the opcode that we used.
What's that?
Not convolve.
Yeah.
Cool. Thanks.
So we're going to incorporate these tools into the classes in Live Sound next year. So it's good.
Just the mixer one as well. We can do, if you want, I can prepare a build, like a VSE build with, like, say 16 input channels, so you could run it in a DAW, so you could just, that might be useful as well.
That would be amazing. Earlier in the year I was working with one of your multi-channel builds. It was an 8-channel build.
Okay, yeah.
And I had it working great in some DAWs, but I had some difficulty with Ableton, so I'd like to talk to you a bit more about that.
Yeah, cool. I'm happy to help in it.
Yeah. Excellent. Thanks, man.
Thank you.
Yes?
Thanks, guys.
Thanks.
Thank you.